Good day BSN Math 2 students. In this video, you are going to learn about congruence. Specifically, you'll get to know the idea of congruence. We'll also have congruence between triangles, the congruence postulates for triangles, and we'll also prove the congruence of triangles. Let's have first the idea of congruence. So two geometric figures are said to be congruent or to be in the relation of congruence if it is possible to superpose one of them on the other so that they coincide throughout. That means congruent figures are of the same size and shape. So it is possible to turn, flip, and or slide one figure so that it will fit exactly on the other figure. The areas of congruent figures are equal as well as their perimeters. Also, the corresponding angles of congruent figures are equal in measure, and the corresponding line segments of congruent figures are equal in length. Now, let's have the following examples of congruent figures. First are two congruent isosceles triangles. So the blue one here, the blue triangle, is just a turn or a rotation of the red triangle. Next, we have two congruent cartoon birds. So the bird on the right is a flip or a reflection of the bird on the left. So it is the flip and slide of the bird on the left. We also have three congruent regular pentagons. So the purple and blue pentagons are slides of the red pentagon. So since all the three pentagons are regular pentagon, meaning all their sides are equal. And so the three pentagons are congruent figures. Next, we have two congruent designs. So the design on the right is a turn or a rotation of the design on the left. We also have two congruent circles. So the circle on the right is a slide or a translation of the circle on the left. As what you can see here, both the circles have 4 as its radius. Lastly, we have here two congruent shapes. So the shape on the right is a slide or a translation of the shape on the left. The order of the letters in the names of congruent figures display the corresponding relationships. So in this manner, even without the diagram, for our trapezoid, you would know that angle A would be congruent to angle R, angle B would be congruent to angle S, and so on. In addition, line segment AB is congruent to line segment RS because these segments are in the same position in each trapezoid's name. So AB and RS. So that means CD and TU are also congruent, and so on. Now, let's proceed to congruence between triangles. So when two triangles are congruent, they will have exactly the same three sides and exactly the same three angles. The equal sides and angles may not be in the same position if there is a turn or a flip, but they are there. So for same sides, when the sides are the same, then the triangles are congruent. Just like in our example, we have here this triangle, which has 5, 4, and 7 as its sides, and then it is congruent to this triangle. And it is also congruent to this one. But our given triangle, this one, is not congruent to this triangle, since 6 and 4 is not equal, meaning this length is longer than this one. So basically, they are not congruent. So if all the sides of two triangles are equal, if all of the corresponding sides of two triangles are equal or are congruent, then we can say that two triangles are congruent. How about if all three corresponding angles of two triangles are the same? So does this guarantee congruence? So not always. So two triangles with the same angles might be congruent, just like this one, but they might not be congruent because of different sizes, just like this. So because even all angles match, one is larger than the other. So this one, this is larger than this triangle. So just having the same angles is not a guarantee that they are congruent. So for the marking, when two triangles are congruent, we often mark corresponding sides and angles just like this. So this triangle is congruent to this one. So the sides marked with one line are equal in length, and similarly for the sides marked with two lines, and also for those sides that are marked with three lines. The angles marked with one arc are equal in size. Also the angles that are marked with two arcs, and for those that are marked with three arcs. Let's now proceed to the congruence postulates for triangles. Let's have first the SSS, or the side-side-side postulate. So this postulate states that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So if triangle CMB has sides identical in measure to the three sides of LSA, then the two triangles are congruent by SSS. So in our illustration, all the corresponding sides of these two triangles are congruent. So by SSS postulate, these two triangles are congruent. Now let's have SAS, or side angle side postulate. So side angle side postulate states that if two sides and the included angle of a triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So the included angle, that is the angle that lies between the two named sides. So for instance, we have here two triangles. We have triangle HUG and triangle KNS. Each have one angle measuring 98 degrees, and the corresponding sides G and S are congruent, as well as the sides H and K. So a side and an included angle and a side on triangle HUG and on triangle KIS are congruent, so by SAS postulate, the true triangles are congruent. Next, we have ASA or angle side angle postulate. So this postulate states that if two angles and the included side of a triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So we have triangle MAK and triangle CHE with side M and C that are congruent. Also, angle A is congruent to angle H, while angle K is also congruent to angle E. So by ASA postulate, these two triangles are congruent. Now we have here AAS or angle-angle side theorem. So this theorem states that if two angles and the non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So we are given two angles in the non-included side, which is the side opposite to one of the angles. So here are the congruent triangles, triangle POT and triangle CAN, with two measured angles of 56 degrees and 52 degrees, and a non-included side that are of the same measurement, and both these sides are opposite to angle 56. So by AAS theorem, these two triangles are congruent. Lastly, we have here HL or hypotenuse leg postulate. So exclusively for right triangles, the HL's postulate tells us that two triangles or two right triangles that have a congruent hypotenuse and a corresponding congruent leg are congruent. So here are right triangles CAT and DOJ with hypotenuses of sides A and O that are congruent, and also the legs C and D are congruent. So by HL postulate, these two triangles are congruent even if they are facing the different directions. Now let's proceed to thinking up your own proof. So given here, for our example 1, is triangle AME and triangle ICE as illustrated. We also know that ME is congruent to CE and AE is congruent to IE. So we have to prove that these two triangles, triangle AME and triangle ICE, are congruent. So for our proof, we have two columns here. Column 1 would be for our statement and the other column would be for our reason. So for our first statement, we know that ME is congruent to CE since it is a given. And then AE is congruent to IE as given. So next, since we already have two corresponding sides from both triangles that are congruent, we have to look for another statement that could lead us to prove that these two triangles are congruent. So observe that triangle MEA and triangle CEI are vertical angles. So by vertical angle theorem, we know that vertical angles are congruent. Thus, these two are congruent. So by side angle side, we can say that triangle AME is congruent to triangle ICE. So that's how we prove the congruence of two triangles. Let's have another example. Let ABCD be a parallelogram and AC be one of its diagonals. Prove that triangle ABC and triangle CDA are congruent. So if we are going to illustrate this, then this is how it would look like. So for our proof, so in a parallelogram, opposite sides are congruent. Hence, the sides BC and AD are congruent, just like AB and CD. And also, the diagonal is a common side of the two triangles. So this AC is congruent to EC since it is common. So by SSS postulate, triangle ABC and triangle CDA are congruent to each other. That's it, class. Thank you so much for watching this video. I do hope that you've learned a lot about congruence. Have a good day, everyone.